right, I'll just get this set up here. Okay. Hello, and thanks for joining us for our Knowledge Sprint series. Today, we're looking at one of the fastest developing areas in technology and, to be honest, the world, artificial intelligence. It is a powerful tool, and like any tool developed during human history, can be used to achieve not only good outcomes, but also inflict harm. In this knowledge sprint, I'll be joined by Chris and Kumar, used by attackers to disrupt businesses and potentially put lives at risk. With this knowledge, we can explore ways to counter these methods. So why should you care? AI is everywhere now. It helps doctors find diseases, powers self-driving cars, it recommends you movies on Netflix, and even helps you chat with your friends online. But if hackers can trick AI, they can impact the outcomes of where AI is used. So it can make self-driving cars ignore stop signs. It can turn a medical AI diagnosis into a misdiagnosis by hiding cancer in an X-ray. It can steal your bank password by fooling security or customer support systems. So what are we going to learn today? Well, we're going to be covering how AI works in simple terms. We'll be looking at how hackers trick artificial intelligence, and we'll understand how to protect AI from these attacks. But first, a little background on who we are. Red Piranha was founded in 2015 out of frustration with the current way cybersecurity is being handled, which put it out of reach of almost everyone except for big businesses that could fund their own teams of cybersecurity experts. From that point forward, under the guidance of our founder, Adam Bennett, Red Piranha has led Australian cybersecurity innovation, which in 2018 saw the launch of Crystal Eye, an award-winning consolidated security platform backed up with threat intelligence and outcome-driven cybersecurity tools and services in the hands of all businesses, from the small operators to the multinational corporations. Our dedication to our mission has seen our contributions to Team Defence Australia and the Cyber Threat Alliance, while attaining ISO certification in 9001 and 27001 standards. Now, all of this technology can be wound up and put in the hands of operations that until recently did not have the means to do so. So our SOC as a service provides a fully managed SOC to our technology partners and end clients with varying levels of autonomy to suit your requirements. Now you've got an understanding of the topic and who we are, here's what we'll be covering in this knowledge sprint. So we'll be asking, is your AI secure? So we'll go over scenarios to answer this question. Like, is your AI's training data clean? Are you using accurate information to train your models? Can your AI handle the tricks? Are there robust guardrails in place to keep your AI model operating within safe limits? We'll also look at what is adversarial AI. We'll explain how hackers cheat. For example, they might add invisible ink or some artifact to an image that might see something different, like instead of a dog, the impact of adversarial AI. We'll look at the detection of adversarial AI. We'll investigate some prevention strategies, and then we'll have some key takeaways at the end of the session. Of course, we'll take your questions. So if you do have any questions, please feel free to put them in the chat on the right-hand side, and we'll cover these questions at the end of the session. So for now, I'm going to hand over to Christian so we can get into the good stuff. Maybe to you, Christian.
Yeah, thanks, Ben. Thanks everyone for joining this session. I'm Krishnan Kumar. I'm working for Red Piranha from last 7.5 years. Total, I have 12 years of expertise in this software industry. So let's start with the first question, that is, how is your AI secure? So when we are asking these questions, actually, we are talking about the data. Actually, there are different components of the AI models and AI models, and those things require the security. So is your AI secure means when we talk the data that is used for the training of this data that is secure. Are you means the AI that you are using having limited access controls? Is the AI means able to sustain the adversarial attacks? Is it able to means when the training of this model is done, whether it is any transparency have been followed? So these things we need to ask before we go deep into these sections. So if we try to sort it out, actually we required some sort of framework. So actually this AI, if you talk about the AI, actually this technology is if you talking about these days, means this technology is taking the world by storm. Means doing some amazing stuffs. You can now write your mails within a second. Also, but at the same time, this technology also introduced some new threats uh, with their impacts. So if you follow the articles, in fact, 4 out of 5 executive today told they have a concern, their own concern regarding using this generative AI. Their concerns are means they are not ready to trust this generative AI, and they have concerns related to cybersecurity. Means this model is cyber proof or not. They have concern related to accuracy, and they have concern related to privacy. So we will try to sort it out. We will try to solve this issue, and if we able to solve this issue, we able to take the full advantage of this technology. So to sort this out, we require some framework, and let us start with this framework. Actually, this is generative AI workflow having total 5 components. The first one is data. We all know the models are trained on the basis of data. Means the training and fine tuning, whatever we done to the model, that will be done from the data. So this is the first component, and we need some sort of security for this data. The second one is the model, means the model that will be built on top of that data. And the last one is the use case, means ultimately we need this model for inferencing, and user will use this model. So these are the three main components, and we are going to discuss in details about the security. We means the attackers, how the user can, how the bad guy will attack on these systems, and how we able to protect them. Apart from that, two other things are also, that is infrastructure and governance, because this LLM model or any type of model is nothing but a software only. So of course we need something to deploy these means this system. So there is one new field that is developed, that is MLOps, who is responsible to develop, to deploy these LLM systems. So this is all about infrastructure, and next is governance. Of course, we need something that will monitor this complete system. Else, uh, it means there will be a lot of drawback from by using for using this system. So we need well monitored, regulated governance that will deal with this system, this application. So if we talk about the AI, actually when it comes to the AI, actually we classified this AI into 6 different types. This differentiation is on the basis of deployment type. Means and it completely depends upon how you are using the AI. So if you see this diagram, if you see on my right hand side, the first one is the means preventive AI, and on the left hand side you will see the generative AI. Preventive AI means if you look back 4 5 years back, means the models are generally prepared on some sort of data, the organizational data, and you basically these types of these models are generally used for the fraud detections, identifying frauds, forecasting demands, as well as if you have to predict disease outbreak. So these type of things, these models are trained on some sort of data, and they are predicting. So basically, these are the predictive AI. But if you see in the last 1.5 or 2 years, 3 years, the generative AI has taken the shapes. And if you see in this chart, in generative AI sections, the first one is the foundational and external models. Means this is the first deployment type for this generative AI. So currently, many renowned company like Meta, DeepSeek, these are providing their own foundational models. That is Llama provided by Meta, and DeepSeek R1 L1 that is provided by the DeepSeek. So these are the foundational models they are providing, and even they are providing their own user interface from which you are sending some sort of data, and you are getting the output over that. The second one is prompt engineering. In this one, in this approach of deployment, you are using the foundational models, and you have your own UI that will be communicating with this model by sort of some sort of API, and you are passing some sort of data, and you are getting the response from that model. But still, you are not able to use the complete advantages of these models. The second one is the RAG. In this approach, in this deployment type, you have means in this one we are in this one you are going to use a little bit more data. Means you have some sort of data, you are going to save this data into means vector database, and then the generative models that will means the open source model will communicate with that data, and whatever the input you will do through your prompt will you will get the output. So this is the RAG, the second approach in generative AI. Sorry, third approach in generative AI. Next one is the fine-tuned model. In this deployment type, basically you are putting your data into the legs of data. Means the model itself, the open source model is fine-tuned over that data. So this is the fourth deployment type. And next one is pre-trained models. In this one, actually this is something that we are not going to do, or even the organization are not going to do, because this required a lot of computational cost and infrastructure cost to develop such a big type of models, means open source model. So these are the basic six deployment types that are common in these days. Okay. So next one is AI system components. Means I try to break the systems so that means the models, how this is built. So basically, these are if you see in this diagram, there are 12 components. One is, and there are three sections. One is data ops, second one is model ops, and third one is DevSecOps. So actually, if you see on my right hand side, data ops means to prepare the model, first of all, we require the data. Means it begins with data, which could include text, image, or structured data sets. So we feed this data into the data preparation, and then clean the data. Means actually, when means you have a number of sources for the data. You can if means it depends upon which type of model or which type of means training you want to give. Means which type of output you want from that model. Either it will be consider if your model is trained on the adversarial AI attack, if your model is trained on mathematical data for the better mathematics question and answers. So it depends completely upon the source of data. So this source can be either a textbook, either it will be images or something from the web. So these data need to be first of all need to be prepared. Means you need to clean this data. Why so? Because it might be some malicious code inside that, and when you do the training on that data, it might give you different type of response. So you have to prepare this data. Then once the data is prepared, then you have to classify the data. This is the second, yeah, the same in data preparation. Then on top of that data, you have to train this model. Once the training is done, then you have to do the validation as well, because you need to know whether this training, this model is giving the expected response or not. Next one is the catalog. Means you need to define the sensitivity of data. Means you have a data from different sources, and you need to classify. Means you need to identify which data having which level of sensitivity. Means on the basis of that, you are able to give the control within your own organization. So you required some feature indexing into that. After that, you have algorithm, and on the basis of that algorithm, this model will work. So if you have already seen in the last slide that I have means total we have a 6 deployment types. So in this one means, so we are going to once the evaluation of data is of done, model evaluation is done, then we have to deploy this model. And there are, I have already explained, there are 6 different ways in which you can deploy this, the complete AI system, generative AI. So or preventive AI. Next, once this model is deployed, then there you require something that will communicate with this model. Either it will be API, either it will be plugin or application that will communicate this model, and then you will serve this model. So this is the component on which the model work. Well, so here again we distributed this component, means this generative AI workflow. So first we will start means actually we need to understand how the bad guy will attack on these components. Okay, so first we will start with the data. So basically, if you talk about the data, how means how to secure this one. So let us understand how the bad guy will attack on this one. So the first one, that is the poisoning the data. Basically, they introduce some inaccuracy into this data, then go into the training and tuning of the model. Means injected at the time of training itself. Of course, your model produce the bad result. So the first one is poisoning. The second one that can happen is exfiltration. In this one, bad guy will directly break your system and pull. It might be possibility that after breaking the system, they will pull the data away from it. The next one is leakage. This is another way, means some sort of exfiltration only, but this might be unintentional. It might be happen from the developing team, that you directly put all your code and means when you are pushing your code into a repository, at that time it might be happen. So what I want to say, these type of attacks can happen on the data. So actually, to protect, the first thing we need to do, means to protect this data from the different type of attacks. Side of this slide, this is a data discovery and classification. So actually, uh, that will change this game. Means if you understand, means if you able to know the source of data from where you are getting this, and uh, you able to clean that data, filter this data, and able to classify this data, then you are going to means whatever the data you are going to use for the training and fine tuning of the model, that will certainly going to give a better output. The next one is cryptography. Means consider by any means if there is any leakage or exfiltration happen into the data. In that case, if you have used the cryptography, uh, means at least it will be not in readable format. Next one is access control. This is the third solution that can be applied on the data. Means we need to know the sensitivity of data. Means up to which level we have to give information. Means up to which level of access we have to give to either the guy who have access to this data. The next one is the monitor. Means we need to place someone in. Means if we know what is happening, then we are able to put some remedies over that. So we need to monitor the logs that will generate from these systems. So this is all about the data. The next one is the model. So actually, the first thing is we are using generative models. So there are different sources, different big companies are providing the models. But it is important, means consider you are using one model. It's you have downloaded from the internet, and it's means it might be case that this is a copy, not a genuine model. So you can consider this model itself as a supply chain management. Means you need to check that as well. Means while downloading this model, means the source from where you are procuring this model. The next one is API. Means this model will be solving through the API. So the attacker might be attacked in the path of that API, and they can theft the model. The next one is plugin. Whenever we are using plugin, we need to be careful for the privilege escalations. The next one is intellectual property. Means consider you are using any model that will be trained on the data that have copyright issue, and you are using that response into your organization for your work. In that case, that will be you can be sued for that. Means using that copyright data. So these are the attacks. These are the things that can be happen with the model. So how to sort out these issues? We need a proper scanner. First of all, we have a different type of a scanner means to scan the network and all those things. So we basically need a scanner that will scan the model on the different type of data sets. Next one is hardening. Means you need to reset your credentials and all those things. Next one is role based access control. Means you need to know again, the sensitivity means how much access you have to give to your means users or employee. The next one is sources. You need to know properly means consider if you are using your any model, and I have already explained that means it is trained on the copyrighted data. So you need to know the sources means from where the data source is. A transparency required in that field means that can be also achieved by the scanner only. Means a scanner can find it out the data that is means some sort of prompting that will be done to the model, and the scanner will be able to identify whether the response we are getting from this model having some copyright issue or not. So this is all about the model. The next one is the use cases. The attack can happen mostly these days, mostly from this section uh, mainly. And one of those is prompt injection. This is on the top 10 list of OWASP these days. So basically, there are two types of prompt injection. The one is internal, second one is external. So in internal means direct or indirect. So in the direct prompt injection, the user who is using this model, they can directly manipulate the AI by altering the input data, and then they able to they able to manipulate the model by doing this prompt injection. The second one approach, indirect approach, consider you are means user is requesting model to analyze some web application, and or any site, any link, and there is some malicious code inside that link, that web application, and while analyzing that uh, means link get injected. So that will be the indirect prompt injections. Next one is denial of service attack. Even these days, also means in the Chat GPT, or even in DeepSeek, you can send this means you can request, you can input through the prompt more faster than what the response they are giving. Means you can so consider a case means you are sending a request in a loop, and you are getting the data from model again and again, again and again. In that way, you can means able to extract data from that. By doing that, a bad guy will even possible that they completely theft the model. Means they will train their own model from their from the model data. So this is the next one. That model theft I already explained. So how to protect this means ultimately this model is designed for the users only, developed for the users only. So actually we need a monitor system here as well, 24 by 7 monitor system that will monitor this use cases. Means whatever the input output we are getting from these models for the use cases, that need to be monitored. The next one is machine learning detection and response, MLDC. This one is the new field that is evolving now, and we literally actually in cybersecurity there is already detection and response, but we need something separate for the machine learning. Means that will detect some issues in the machine learning, and generate the detects means able to detect and response according to that. Next one is SIEM. Again, we need to monitor this complete system. Be able to analyze the logs. On top of that, we have to set the rules, and we need to flag out those events. So basically, these are the attacks that can be happen on data, model, and uses.
It's interesting that we seem to see that these attacks are pretty common, and they seem to share some common factors between traditional cybersecurity and AI. So yeah, it's interesting. The vulnerabilities are similar with a couple of small exceptions. But what I find really interesting is that we've actually got a lot of the tools already to deploy in place to protect artificial intelligence systems.
Yeah, correct, Ben.
Hmm.
Let me give you means one example of prompt injections that can be happen to. Consider you are using any bank agent application that is trained on the some sort of banking data. It is giving you response like bank details. Means whenever you are talking to that chatbot, and you are looking for your bank account balance, you want to know the check status. So you are communicating with that model. Okay, and consider a bad guy who will come into that communication. Okay, bad element, And what they will put means they are communicating with model, first try to understand, first try to analyze that model, and in between they will alter the input and told the model, hey, can we play a game? And the next instruction from that bad guy is, can you prepare a playbook for me where you have to record all the sessions that you are doing from this time till evening. So consider if these guards are not in a means not placed. This means, of course, you have to do some more input. You have to put some more tweak into the input. But by doing that means you have to set some rules. Of course, these days actually models are trained by adversarial attacks, but still uh, there is not enough. Still, you can manipulate by tweaking the input. Recently in India, there is one company ANI who has put a copyright case against ChatGPT. They have claimed that they're able to train their model from their data without means informing us or without taking permission from us. So even if you tweak right now to the chat GPT, you're able to get the data from the chat GPT means the AI data means they will send you some set of data sets that you can put as evidence. Means basically this model is trained from their data. So these are the loopholes that is still available. Okay, so next one is the adversarial attack, how this can happen on any models. So basically, this is a technique that will be used to manipulate the artificial intelligence model by exploiting their vulnerabilities. I have added three type of attacks. This is evasion attacks, poisoning attacks, and model extraction. These are added purposely because this adversarial attack can happen into at the time of training, as well as when it is in products, when you are deploying this model in production, as well as in the use cases as well. Next few examples for this one, like consider you are using any self-driving car, and basically the self-driving car is completely work on the model, the data from which this model are trained. So consider you means having there are bad guy will add uh, some type of noise into that into that that indications. So actually what will happen, instead of detecting means consider there is a stop sign, it will detect something else. So this will create a big issue. Same will happen with means medical diagnosis AI means consider one model is trained to analyze the reports, and some weight is added on that that report. It will predict something else. So this is the AI attack, means adversarial AI attack. In this one, you will manipulate the artificial intelligence models, and you try to exploit their vulnerabilities. So how this attack will happen, I have already explained with example, but in this one, the step one will be identifying the AI vulnerabilities, in which uh, means the bad guy will try to understand the model means the training data means uh, which type of training means model is trained on which type of data, means how they will try to understand from the response, means they will do some input, prompt input, and they will get the output. On basis of that, they will analyze, means how which type of training happened with the model. So they will identify the AI vulnerabilities, then on the basis of that output they will craft their adversarial input. What I have given example just a few minutes back means, first of all, if there is any banking agent chatbot, I will communicate with that model for the general details like banking, bank balance, or a checkbook status. And once I find out there is a issue input, means I able to craft that adversarial input, and will try to put that input into the model. Next one is exploiting the AI model. Yeah. So once the input is passed, they will means they able to craft this adversarial input. They will exploit this model, and they able to achieve their attack goals. So actually, in this slide, I am suggesting some controls that will be uh, applied for preventing adversarial AI attack. So the first one is means currently, of course, this one is the evolving technology, and we don't have such a means no universal set of AI specific controls that will be fully standardized for the managing AI programs against threats. So I'm suggesting some controls for this one. The first one is AI monitoring threat detections. So we need, I have already explained in last slide, that is MLDC means we need something that will detect, uh, means that will able to monitor the machine learning algorithms and able to generate some logs. So this is AI monitoring and threat detection. Next one is AI protection and AI data protection and privacy controls, means some sort of protection for the data. Next one is AI model security and adversarial defense. Of adversarial data. The model, this is most important because means this will completely break the model if the model is not trained on this adversarial defense. Next one is vulnerability scanning and AI red teaming. This is the scanner, means we required any scanner that will scan the models, and at the same time we need some sort of automatic error teaming things, so that it will evaluate the systems against those defenses. Next one is AI governance and compliance control, means we literally need to regulate this one from the government side, or so that the models will not work on the bias. Next one is education. Why I have added this one? Because this technology is evolving, and every day something new is coming into the market. So it's important to understand the attacks, the new features that is evolve in this AI, and make guards for that, develop guards for that. So next one is the multi-layered, means we have suggested 5 layers to protect this complete system from these types of attacks. So the first one is, let's dive into the layer one, that is data level security and pre-processing. So this is very first line of defense. Whenever you are building any secure AI systems, no matter how strong your algorithm are, means whatever the code means you have written, we all know that if the training data that is used to train and fine tune this model, if that data is compromised, the model can be too compromised. So we need to make sure that this data is clean, unbiased, private and trustworthy before we train the models. So if you so in my last slide, I have suggested AI scanner and AI red teaming process. So this is the place where the AI red teaming and model scanner means comes into the play. So here AI model scanner must be built to automatically inspect and means analyze the data sets before training. Means the AI model must able to analyze these data sets even before we start the training. So actually, what if you see, so what the AI model scanner will do? Actually, it will look for few things. The one of those things is data poisoning attempts. The second one is means skewed privacy. If there is any leaks in that. The next one that is if there is any means, consider you have built some feature for that model and there are some risky feature sets that need to be evaluated. At the same time, the AI red teaming can be put into guard so that they will evaluate whatever the means means whatever the guards already put into that, means they will evaluate those systems and uh, check whether means they can simulate poisoning attack, they can manipulate feature distribution to see how the models and data pipelines will react. So these things can be done from the red teaming sites. So both can be used in this layer so that we able to protect the data level security and pre-processings. In the next slide, that is model level defense. So actually, we need to train our model on the adversarial data. Uh, there are a lot of research going on in this field, and a lot of researchers have suggested a lot of solutions for this one. So the model need to be trained uh, on the adversarial attack data, so that it able to give the response, it able to protect themselves from whatever the adversarial things happen from the input sides. Sorry, just a minute.
All good there, mate? Whoops. Looks like Christian has knocked something. We'll wait for him to come back. But in the meantime, I've asked the question of real world examples that our attendees can think of. So, we've had Prasanna think of backdoor attacks and inserting hidden triggers in AI models to activate malicious behavior later. So effectively a time bomb linked to a backdoor. So quite interesting. That's a good one. And Samir says threat actors are using artificial intelligence for discovery of vulnerabilities and use AI to exploit it without getting noticed. Yeah, stealthy exploitation. It's pretty much the attacker's bag, that's for sure. All right, looks like you're back. You good? Almost there, Christian. No, I can't quite hear you, mate. Looks like you're on mute for some reason, or your audio's not turned on. Nope. Okay, so camera's off. No. Looks like Christian is having some struggles with technology. What I might do while we're waiting, yeah, Jason's question, I'll leave that for Q&A at the end of this. But what I can do is that I can let you know about upcoming events. So we have some events coming up. So on May the 29th, we've got Crystal Eye Essentials Module 1. And this is going to be geared towards Crystal Eye 5.5 and recent updates we've had with Orchestrate. And then following on a week from that is the Crystal Eye Essentials Module 2. So these are all very important for just getting started with your Crystal Eye journey. All right, are we back?
Still target the model itself by tweaking it with carefully, means by crafting their inputs, stealing its behavior, or even activating hidden backdoors. So actually, we need to build models that can withstand these manipulations. So just like you are using antivirus protection for a laptop, we need to protect this model from tricks like evasion attacks, model theft, and backdoor insertions. So again, for that also we need to use our one of the controls, that is uh, means MLDC, the machine learning detection response, means 24-hour monitoring, that will monitor the system, means whatever the input given by the from the user side, and we need to monitor how the model is responding for those inputs. We need to log the weights, these things from the model response. So these things need to be monitored on the layer 2. I means we need to protect our models from any type of adversaries. Next one is input output validations. This is the most important part, because ultimately we are going to use this model by from the use cases only. So this is one of the main component which need to be protected. So if we talk about this layer, input and output validation, actually this is like AI immune systems. Means you need to you need to check constantly, means here you need one of our controls that will monitor the system 24 by 7, means whatever the input that is coming from the user side, that need to be means analyzed from the monitors that we will put into the background. So here also we need either MLDC, means machine learning detection, the same C modules to monitor those inputs, and as well as how the models are responding as well, because if by any means we able to miss that input, and the model is already started behaving in a different way, we need to put it down. So this is all about the the third layer, input and output validations. The next one is secure deployment and access control. We have already discussed that ultimately this is software and we need to deploy this one. I have discussed in details about the 6 type of deployment, AI deployment types, the prompt engineering for the the preventive AI, so and generative AI. So we need to while deploying these models, we need to safeguard AI models during deployments from any type of unauthorized access, data leaks, and manipulation. This again can be done through the scanner. Means a scanner will detect these things while doing automatic 24/7 scans. So for that, we need to do the data sanitization and poisoning detections. Need to check whether means whatever the means means diverse and bias free training data sets, means the training we have given to this model, that data will be certainly unbiased. Means let me give you an example. Consider any bank is using any model for giving the loans, and that model is biased for the women's. Means we are putting some sets of means we are giving some sets of data to that model to analyze whether this person is eligible for the loans or not. But the training is happen like that, it will be unbiased for the women. So these things need to be taken care. Next one is continuous monitoring and incident response. So actually, it's important to detect adversaries in real time and implement automated mitigation measure to protect AI operations. Means we need SIEM as well as MLDC to continuously monitor from either it will be data, either it will be model, either it will be from the users, either it will be the use cases. So for that, we need to we need to implement these real-time detection, real-time anomaly detections, self-healing AI models, some sort of threat intelligence and logging systems, so that we able to monitor this complete system properly. So these are the 5 layers that can be implemented with those security controls over the complete deployments that have been done for the for with respective use cases. So key takeaways. So we have learned AI is double-edged sword, because if we use it, but if we use this with bad training data, it will be create a lot of blunders. Means it will create issues. So second one, adversarial AI is growing concern. Yeah, this is one of the top issues currently, that means a lot of research is going on these fields. Third one, human AI collaboration is critical. Yeah, we are we are these days we are dependent on the automatic systems, but we still need human in a loop. Means there are some places, means if you see in this deployment, complete AI deployment, we need a lot of human collaboration to detect the input and output responses. So important of robust defense mechanism means the controls that we have put to safeguard these data models and the use cases. We need means SIEM as well as MLDC for to protect these systems.
Okay, fantastic. Thanks very much for that, Christian. That's a very informative presentation. I enjoyed it. I hope everyone else enjoyed it as well. Now, let's quickly flip over to our Q&A part. So we've got a question from Jason asking the question, how are you incorporating artificial intelligence in Crystal Eye, and describe how your artificial intelligence will help customers? I can handle this one easily. Thanks very much for that question. Okay, artificial intelligence and machine learning is actually being used in our detection. So we are leveraging that currently for detecting traffic anomalies and also pattern recognition. And we are also just about to release our large language model support. So this is the Crystal AI, which is a support tool that goes straight into the Crystal Eye user interface, and it references our existing support documentation. So instead of having to go to the documentation, you can just simply ask a question inside the user interface, and it'll describe what to do next. So I think that's going to be quite a useful tool, and we are also constantly working on machine learning and artificial intelligence, and the focus is now moving towards the response part of the equation. So we've got the detection, we're using that for, and that's also helping us to generate a lot of threat intelligence too. If you've got any other questions, now is a great time. While we're waiting for more of these questions to come through, a reminder that we do have another upcoming knowledge sprint coming. This is the scenario-based threat hunting. You can find more details at redpiranha.net/events. This is going to be covering lateral movement, internal reconnaissance, data exfiltration, and anomalous network behavior, and how we detect all these things, specifically using Crystal Eye tools and our threat hunt dashboard. Now, if there aren't any more questions, I think we can probably wrap this up. We've gone over time a little bit. But thank you all for your patience and for sticking with us, and we'll look forward to catching you again next time. I'll just roll the video, and we'll see you later. Bye.